Hello, assalamu alaikum everybody. This is a part of our assignment, which was assigned by Dr. Satikundu Choudhury, and each person was given a question which we have to solve it. And my question was about utility function representing the preference relation. Before drawing the question, I would like to discuss some theories that would eventually help us to understand the solution. And we would like to talk about the utility function and the preference relation. At first, I would like to define it. A real valued function u such that Rn plus is a real number, and that implies real number is called utility function representing the preference relation. If for all x0 and x1, which is element of Rn plus 1, the utility of x0 is greater than or equal to utility of x1, and x0 is at least as good as x1, both implies both, which is a vice versa relation. That means any binary relation that is complete, transitive, and continuous can be represented by a continuous real valued utility function, and we could put an extra requirement which is strictly monotony, but we can easily avoid the convexity. Now, I would like to introduce the existence theorem, where existence of a real valued function representing the preference relation is defined by the following. If the binary relation is complete, transitive, continuous, and strictly monotonic, there exists a continuous real valued function u such that Rn plus implies real number, which represents the preference relation. Now, the question. Consider an individual with a rational preference relation such that a preference relation that satisfies completeness and transitivity. Show that if utility of x is equal to utility of y implies x is indifferent to y, and utility of x is greater than utility of y implies x is more preferred to y, then u dot is a utility function that represents this individual's preference relation. To solve this problem, I would like to discuss this in two ways. At first, we need to show that utility function or the u dot is a utility function representing the preference relation. And to show that we can recall the definition of utility function. And here we can see that this x is at least as preferred as y, and the utility of x is greater than or equal to utility of y. Both implies each thing. Vice versa. There is a vice versa relation. So solve this first. We show that x is at least as good as y implies utility of x is greater than or equal to utility of y. Then we will show the converse such that utility of x is greater than or equal to utility of y implies x is at least as good as y. At first, suppose x is at least as good as y. If in addition y is also at least as good as y, then it must be x is indifferent to y and the consumer is indifferent between x and y, which implies that utility of x is equal to utility of y. If instead y is not preferred to x, then obviously x is preferred to y and the consumer strictly prefers x to y, which implies utility of x is greater than utility of y. Thus, we have shown that if x is at least as preferred as y, then obviously utility of x is greater than utility of y. Secondly, let us show the opposite line of implication. Suppose utility of x is greater than or equal utility of y. This implies that either utility of x is greater than utility of y or utility of x is equal to utility of y. In the first case, this implies that x is preferred to y. X is obviously more preferred to y, which is x is at least as good as y, and y is not preferred to x. In the second case, it implies that x is indifferent to y. Here, x is indifferent to y, such that x is at least as good as y and y is at least as good as x. Hence, we have shown that if the utility of x is greater than or equal to utility of y, then obviously x is at least as good as y, or there is a preference relation between x and y. Thank you for your patience.